I think we're aware that we could generally categorize mosquitoes by their larval habitat and as either floodwater container or standing water breeders. And California's 8 genera fit pretty well within this organization with some exceptions. That said, the definition of floodwater, particularly in a state as large as California and as diverse as it is, it encompasses a wide spectrum from springtime snow pools in our mountain areas such as Alpine County to coastal salt marshes to seasonal wetlands, either natural or constructed, like here in the Central Valley, or irrigated agriculture throughout the state. A lot of it is in the Central Valley, but many other regions of the state, including here in the desert Southeast. So with all that diversity, how do you define floodwater? For this talk, I would say it is water that's introduced onto a landscape for a limited amount of time. For mosquito control purposes, it's the new introduction of water that's there long enough to allow mosquitoes to develop to adults. And admittedly, if it's there any longer, standing water transitions to become semi-permanent or permanent, which can lead to breeding of other mosquitoes, which is kind of beyond the scope of what I'm going to talk about this morning. Also admittedly, not all floodwater produces floodwater mosquitoes. As an example, this levee breach in San Joaquin County in 2004 flooded over 12,000 acres up to 10 feet or more. Floodwater mosquito eggs in this area were either washed away, buried, or the larvae didn't survive to mature. However, in this case, portions of this flooded area remained for weeks or months later and did transition to semi-permanent habitat, which produced significant culex breeding and issues for the local control agency. There's a view of how extensive that was. By my count, using county collection records in this publication, Mosquitoes of California, which is about 20 years old now, but listed 53 species, and adding the 3 invasive Aedes, container breeding Aedes that have been more recently introduced into the state, I come up with, I believe we have 56 species currently in California. Of those, I would consider about almost half to be floodwater species, and that includes about 80% of the Aedes species in California and our 2 Serophora species. Here's a quick look at those 25 floodwater species. More than half of these are univoltine, meaning they produce just 1 generation a year. Those are the ones marked by the asterisk. Of these univoltine mosquitoes, quite a few of them, the majority I believe, are considered snow pool mosquitoes, ones that typically occur in our mountainous areas and where we only have a few vector control agencies that operate and have to deal with these. At this point, I'd like to just briefly explain the title of my presentation about being overlooked vectors. Admittedly, most of these species that I'm talking about are not transmitters of human pathogens, or to a significant extent, they would pale in comparison to the significance of some of our culex species, the vector West Nile virus and St. Louis and other encephalitis viruses. However, many of our floodwater Aedes can be very abundant, particularly if uncontrolled, and many of them are vicious biters of humans. Therefore, their pestiferous nature fits well within the legal definition of California in our health and safety code, as Rob Miller here from the Owens Valley on the east side of the Sierra demonstrates with his head count of Aedes melanomen. The other aspect of being overlooked that I want to mention is kind of struck me as I was looking for some background material in this publication, annual publication of the Mosquito and Vector Control Association of California. It gives you a feel for what the topics of interest of the day are. I did a quick unscientific tally of the table of contents, and as you can see, in the past 20 years, talks and papers in this publication were dominated by culex. species, and rightly so because of their importance as a West Nile virus vector. And then in recent years, a lot of invasive Aedes because of the 3 recent introductions we've had in the state. But it's been really hard to find in the last 20 years very many publications about floodwater mosquitoes. And if you could go back into this same publication and look back a few decades earlier, you see that floodwater mosquito subjects or topics were much more of interest. So in this historic sense, I'd say these species are somewhat overlooked these days. So it's great we're getting the opportunity to discuss them in a symposium like this. While they may be somewhat overlooked, I don't think they're any less relevant today or less abundant. As examples, I borrowed this table from Butte County's annual report, and you can see Aedes melanoma, a floodwater mosquito, is typically represents the majority of their New Jersey light trap collections within the district annually, and this is typical pretty much year to year up there. If you move a little further south down to the Sacramento-Yolo area, you can see that maybe district-wide Aedes melanoma here doesn't represent a majority, in fact, a fairly small amount district-wide, but this is a more suburbanized, urbanized environment. If you do look at parts of the district that are still more agricultural and have more wetlands, you see in these areas, melanoma and other floodwater mosquito species can represent a significant portion of their New Jersey light trap collections. Let's shift quickly to some the adaptations floodwater mosquitoes use to take advantage of this transient habitat. Unlike Culex and Anopheles, they don't lay their eggs on the water, but they lay it singly on the ground adjacent to or above the water line. Once the eggs are conditioned, they can hatch upon flooding, or they can remain dormant in a diapause stage until conditions are suitable for hatching and survival. Many of the eggs are very resistant to desiccation, so they can survive for months, if not years. Not all the eggs will hatch at once upon flooding, so they can increase their chances of survival in the habitats. Some species can develop very rapidly, particularly when the temperature is very warm. And egg-laying females use a variety of cues identified by sight, smell, touch to identify appropriate locations to lay their eggs, which also enhances their survival or propagation, and to avoid inhospitable locations. In addition to these adaptations, the wide variety of habitats that I just went over can make control quite challenging. So for the remainder of the talk, I'd like to provide some examples using this kind of paradigm that Valent Biosciences has on their webpage, where they generally divide all floodwater habitats up into these 4 biotypes. Seemed like an appropriate format for this venue. So starting with our coastal habitats or biotypes, in California, we have 3 species that occur here. Aedes squamager is the subject of a later talk, so I'll use Aedes dorsalis as an example. This species isn't strictly a salt marsh species. It is also found inland in alkaline areas of parts of the state. As such, the larvae are tolerant of quite high salt content in the water. It can have many generations in a season and be abundant from spring to fall. Can bite voraciously, and females will fly significant distances to find a blood meal. A couple of notes on these distribution maps I'm going to show. The map on the left is a compilation of the county records from that publication I showed earlier. The map on the right is a spatial interpolation or heat map, which is summarizing CO2 trap data from 2016 to 2019 that vector control agencies in California have entered into the CalSurv database. The way you interpret this map is anywhere where you see a color, that's where vector control agencies are reporting surveillance data. Where you see the darkest green, they have found no species or no individuals of the species I'm showing. And then as the colors ramp up, obviously more numbers of that species are being found. So in this case, we see dorsalis is most commonly collected in the San Francisco Bay Area, up here in the kind of the center of the state, but also found down in coastal areas. And as I mentioned, they do occur more inland, both in the Central Valley and in the desert southeast. If you want more information on this CalServe capabilities or vector serve for the rest of the US, Dr. Chris Barker has some good YouTube videos available, and it's a very useful tool. For the next biotype, the floodplain, a common example of this in California are riparian corridors that flood seasonally due to spring rains or runoff from snow melt in the mountains. Flooding due to summer rains is a common event in California. So in this case, these riparian corridors do produce some floodplain mosquitoes. I'm going to use Aedes vexans as an example. It is one of the most commonly occurring, widely distributed species in the world, and it's also very widespread in California, occurring everywhere except the higher elevations and some of the coastal areas. It breeds in other biotypes found in the state, but it is fairly common in these flooded riparian areas. It can be a dog heartworm vector, but it pales in comparison to Aedes sierrensis, which is a tree-hole breeding mosquito, common in California. In the distribution maps, you could see county collection records everywhere but the coastal areas. In more recent years, numbers of this species are being collected all the way from the far north in Shasta down on the Mexican border, the Colorado River Valley, and even on the east side of the Sierras. So pretty common occurrence in California, except most of the coastal areas. However, even though there aren't county collection records in recent years, Orange County and LA County have been finding some Aedes vexans in their collections. The irrigation floodwater biotype is probably the most significant producer of floodwater mosquitoes in the state. This biotype includes a variety of habitats like irrigated crops, flooded pastures, rice fields, particularly when reflooded in the fall, and seasonally flooded refuges and duck clubs. There's a few species I'd like to mention here because of the importance of this habitat. Starting with Aedes melanimum, this is probably the most abundant problematic floodwater species, certainly in the Central Valley, but many other areas of the state. Also multivoltine. It's a very persistent biter. In this case, there is some public health significance as it's a secondary vector of Western equine encephalomyelitis virus and also a vector of California encephalitis virus, particularly in the Central Valley. As you can see from the heat map, it is quite abundant in high numbers, especially through the Central Valley and on the east side of the Sierra, where Rob Miller in that earlier picture demonstrated. Very common in the summer and very pestiferous. From the same habitat, I'd also like to briefly mention Aedes nigromaculus, which was a relatively recent introduction into California, being first found up in Shasta County in 1937, quickly became one of the most problematic and abundant floodwater mosquitoes in the state. It often occurs with Aedes melanimum. However, it's a little less tolerant of salt content in the water than melanimum is. It develops quite rapidly in the summertime when temperatures are warm and can go from egg to adult in just a few days. And the adults peak in the hot summer months, whereas melanimum tends to peak more in the spring and fall months where they're found together. In this distribution map, you could see similar to Aedes melanimum, it's found abundantly throughout the Central Valley, but in less abundant numbers, as you saw with melanimum. Not sure why melanimum is dominating in recent decades compared to the 1950s or 60s, but it might be to a variety of things like a more judicious use of irrigated water or less types of certain crops or less pasture, irrigated pastures. So it's probably some combination of better water management and different habitats compared to 70 years ago. One other irrigated biotype species I'd like to mention for some regional diversity is Serophora columbia, While restricted to the southeast deserts counties of the state, it can be very problematic if uncontrolled, particularly in and around irrigated ag lands, especially in date palm irrigation, as you see in that bottom right picture from the Coachella Valley. Like Aedes nigromaculus, it can develop quite rapidly from egg to adult in the hot summer months, and it peaks in abundance down in the southeastern desert areas from June to September. The final floodwater biotype example I'd like to mention is the woodland or snow pole habitat. This includes seasonally flooded areas and snow poles. These species found here are typically univoltine or single generation species, but in wet years they can create significant annoyance problems. And as an example of this biotype, a mosquito that occurs here, I'd like to mention Aedes increpidus, which in California is actually a complex of 3 species, increpidus, clivus, and washinoi. The adults are morphologically indistinguishable. Washinoi typically occurs in coastal areas and the only one found in the Central Valley, whereas clivus and crepidus are found on the west and east slopes of the Sierras and Cascades, respectively. It's typically considered univoltine, but washinoi, I think, is probably multivoltine. You could see it's found quite a bit in Southern California. These would be washinoi, and talking agencies down there, many of them see this species for many months of the year, suggesting it is multi-generational. But with these 3 species together, you could see they're broadly found throughout the state, not only coastal areas, inland, and even on the east side of the Sierras. As a segue to the following talks, I know a lot of times vector control isn't in control of the water or the flooding of these habitats, but there are a wide variety of integrated management methods that can be recommended or promoted, depending on the site, that will help minimize mosquito production and hopefully minimize the need for pesticide applications. But and oftentimes those need to occur to augment these other physical, cultural, and biological control methods. So with that, I just want to thank the folks at the vector control agencies, various ones that I applied for local information or provided a lot of nice pictures. And thanks to Tony Novak of our section, who provided the mapping of the CalServe data. And with that, I am finished.